IPv6 or Internet Protocol version 6. The previous version was v4, this one is v6. If you go to your computer, you will see in TCP/IP, this kind of number you will give. For the first time, it may seem complicated because it is all hexadecimal. The IPv4 was all numeric. So IPv6 address example is like this. This is a very simple example I have taken. So IPv6 or Internet Protocol version 6. This was deployed. This was started in discussion when we had the high demand for IP addresses, because IPv4 only 32-bit address, so it can only cater up to 4.29 billion addresses. We are 8 billion people. Every person is having 2-3 gadgets now. So this is the most recent generation of Internet Protocol IP. It was introduced in 1998 in different articles or website. You will see 1995 also. 2017 is the latest one. Basically, when it was actually agreed on IETF, I'll just show you. That was 1998. So this was defined. This is defined in RFC 2460, defined by the IETF Internet Engineering Task Force, and that is how we have got this 1998 number or the year. So IPv6, it is not only solving the problem of limited network addresses resources, because the problem with IPv4 was that. But this IPv6 is also resolving the barriers for multiple access devices to connect to the internet. A IPv6 address, which you see here. First of all, it is a 128-bit hexadecimal number. Two things you have to remember. 128-bit hexadecimal number. IPv4 was what? Totally numeric. 1 octet, that is from 0 to 255, one group or field can go value. IPv4 was decimal. That is why it was called as decimal dotted notation. But here you have 0 to 9 and A to F is also included. So all in all, you have 16 of them, 0 to F. F correspond to 50. So we have hexadecimal address being used. And since we have colon in between, IPv6 is a 128-bit IP address. Previously, IPv4 was 32-bit addressing scheme. So 2 to the power 32 you can address. Here you can address, or you can give the address individually to all the system in the world. 128, 2 to the power 128, and that number is huge. Now new terminology was invented. 340 undecillion. So 3.403 into 10 to the power 38. Not only you take the Andromeda galaxy, you take all the whole solar system, and you have people there. You can assign the number and addresses to their machine. All right. Please recall, IPv4 was 32-bit address. It can only cater to 2 to the power 32-bit, that is 4.29 billion addresses. But IPv6, 340 undecillion. So we have here 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 sets, 8 field or 8 groups. How are they separated? They are separated by a colon. That is 2 dots vertically. This is the colon. So these are separated by colon. Each set, field or group, these are 16-bit. 16, how many are there? 8. 16 into 8 is what? 6 8s are 48, 8 4 carries, 8 1s are 8, 8 1s are 8, 12. 128-bit has come from there. Hexadecimal I already told you, and each hexadecimal character is representing 4 bits. For example, O, D, B, 8. This 0 or O, it will not be O, it will always be 0. We just have from A to F. So every D, B, 8, all these are 4 bits. So that is why we have 4 of them, and 1 is 4 bits, so 4 4s are 16. So one group or one field or one set is 16-bit. Each hexadecimal 4-bit. This hexadecimal address, it contains not only the numbers. Unlike the IPv4, it has alphabets also. A to F we are employing. Now what is the meaning of different sections of IPv6? Because it seems complicated at first sight, but it's not if you understand each part. So we'll take the same example. This is a very simple example. 16-bit I showed you, 128 bits how it has come. So one of these, which is the one of the first part. The 2 is a global unicast address indicator. what it is referring? It is referring to sending message to a single network destination which is identified by a unique address, which is this whole address. So the first number, or you can say the first in that field or group, the first hexadecimal value is corresponding to the global unicast address indicator. The second one, which is complete 001 here, I am taking the first one only, first group. 001, this is corresponding to a region. It can be Africa, it can be Latin America, like that. We have 0DB8 here, and this in this example is called the Local Internet Registry, or LIR, or also you can just say that it is the identification of the Internet Service Provider, ISP. The AC10, this is for you, who is the customer. So AC, there is a service provider, there will be a customer also, AC10, that is corresponding to it. Then we have FE01, this is a subnet. So there are different networks, the networks have their subnetwork that are called as subnets. Okay, subnetwork. So that is the number FE01. And after that we have 4 more of these numbers which are, or the hexadecimal numbers separated by column. This whole is a 64-bit extended unique identifier, EUI64. Okay, extended unique identifier, and this is especially for your computer, your system. So this unique EUI64, which is a 64-bit IP version 6 interface identifier, this is assigned directly to the host, that is your computer, without any manual configuration or even DHCP. You don't have to do DHCP or manual configuration. It is assigned like that. So this is the final part which is called as EUI64. That is how you can remember.